there. Okay, so we're looking at this sequence, and we need a general term for this sequence. So similar to the last one, I think it's just going to be 3/4 to the power of n. So when n is 1, no, sorry, for the first sequence it was 0, wasn't it? Yeah. So here, so if we make n 0, it becomes 3/4 to the power of 0, which is 1. Then for this sequence here, this one here, you with me? N is 1. So that gives you 3/4 to the power of 1, which is 3/4. This one here, n is 2. So you've got 3/4 to the power of 2, which is 9/16. Okay, so that is the general term of the sequence. That works. So we're looking for where that's 3/4 to the power of n is less than 1/100. Yeah? So it's the same thing we did just up above there. We want to get this n out, so we're going to have to do log to the base 3/4 of both sides. Log to the base 3/4 of the left will cancel them and give me the n isolated. Now, when you take the log of a fraction, when you take the log of a fraction, that's the same as multiplying by a minus. And when you multiply an inequality by a minus, you have to switch the inequality. Okay? So when that's the log, when the base of the log is a fraction, it has to be a proper fraction. Now, it can't be top heavy, it has to be proper. But when it's a proper fraction, it's the same as multiplying by a minus, and you need to switch the inequality. So log to the base 3/4 of 1/100. I'm getting 16.0078. There's more stuff. So if n is greater than 16.0, then n is equal to 17. Okay, so when n is 17, the fraction remaining is less than 0.01. So you can check it. 3/4 to the power of 17. Yeah, it's giving me 0.0075. So that's definitely smaller than 0.01. Yeah? So what fraction of the original triangle remains after an infinite number of steps? Now, I just want to look at this because sometimes this formula, because I feel like we should do this, but I'm pretty sure this isn't going to work. So a is 1/1 minus 3/4. That's 1/1/4, which is 4. Okay, so that doesn't make any sense. It doesn't make any sense that there would be, I mean, what does that even mean? There would be 4 triangles remaining when we remove all the triangles from it? That doesn't make any sense. So, I mean, I think it's, I don't know, is it obvious? It's obvious that if you keep removing equilateral triangles from the black triangles, that you're going to end up, the limit you're approaching is definitely 0. So what fraction of the original triangle remains after an infinite number of steps? We are talking about a limit approaching 0. Has to be. So the limits, as n approaches infinity, of 3/4 to the power of n. So what happens to a fraction as the power approaches infinity? So if I do 3/4 to the power of 10, I get 0.056. If I do 3/4 to the power of 100, yeah, I'm getting 3.2 by 10 to the minus 13. That's tiny. I don't know if it'll let me go any bigger. Let's try 3/4 to the power of 200. Yeah, so now I'm down to 200. I'm at 1.029 by 10 to the minus 25. Yeah? So, as n, as the power is getting bigger and bigger, So approaching infinity, which is what they asked me. These numbers that I'm getting for answers are getting smaller and smaller. So as it kind of makes sense, as you take more and more triangles out, the amount of the original triangle remaining is going to approach 0. That's a bit of a tricky one because the formula doesn't work for it. Right, the side length of the triangle in step 0 is 1 unit. The table shows the total perimeter of all the black triangles in each of the first 5 steps. Okay, so the perimeter of the first one is going to be 1, 2, 3. Now the perimeter here, so this is going to be a half, right? A half, and then a half, and this one here is a half, and then a half. Is that right? Is it all the black triangles? The side length of the triangle is that. The table shows the total perimeter of all the black triangles in the first. Okay, so that's going to be how many halves? 1, 2, 3, 4, 5, 6, 7, 8, 9 halves. So put in 9 over 2. The next one apparently is 27 over 4, which means we should be done counting and I should be able to figure out. So this is 3 over 1. So what's going on there? I'm multiplying by 3 over 2. Top line by 3, bottom line by 2. Yes, I am. Top line by 3, bottom line by 2. So 27 over 4 multiplied by 3 over 2 gives me 81 over 8. Multiplied, 81 over 8 multiplied by 3 over 2 is 243 over 16. Find the total perimeter of the black triangles in step 35 of the pattern. Okay, so what's the sequence? So I'm going to have to use Tn is a or to the n minus 1. But just be careful that I can't use step 0 as my a. I have to use step 1 as my a. So just be careful because that formula, it has to be step 1. So it's 9 over 2 by 3 over 2 to the power of... does that make sense? Let's see, to the power of 1 minus 1. So that's just going to be 9 over 2. Oh no, what am I doing? Sorry. I don't want to sub in yet. To the power of n minus 1. Okay, so that's what I think the formula is. So let's see if it makes sense. So when n is 0, I should get a perimeter of 3. Yeah? So if I make n 0, I get 9 over 2 by 3 over 2. This doesn't feel right. To the power of 0 minus 1. That's 9 over 2 by 3 over 2 to the minus 1. Oh, it does work. That's 3. So the second one, if I make, for this one here, if I make n1, I should get 9 over 2 by 3 over 2 to the 1 minus 1. So that is 9 over 2 by 3 over 2 to the 0. 3 over 2 to the 0 is 1. So that's 9 over 2. Okay, so it is working, right? So I want to know how many in step 35. So I just make that 35. Power. So if I'm looking for step 1, I make n1. Yeah, so if I'm looking for step 35, I make n35. Ugh. Okay, I'm getting this number. 4368328.818. So 4368329. units is the length of the perimeter. All right. 4368329. Cool. Okay. Last part. Use your answers to C part 2. Oh, C part 2. Oh, this infinity one. And D part 2, which is that one, to comment on the total area and the total perimeter of the black triangles in step n of the pattern as n tends towards infinity. Okay, well, the area we already talked about. So as n approaches infinity, the area approaches 0. Yeah, sorry, I should be a little bit more specific. The area of black triangle approaches 0. Yeah, so as you continue on, as you continue taking triangles out, the area of the black triangle approaches 0. And the perimeter, it seems, like the perimeter in the first one was 3, the perimeter in the second one was 4.5. Then it went to 27 over 4, which is 6.75. Then it went to 81 over 8, which is 10.125. Like 243 divided by 16 is 15.18. And then when I get to step 35, I'm up to this, which is over 4 million. So it feels as if for this one, as n, sorry, get that back to an S, as n approaches infinity, the perimeter also approaches infinity. Oh, that's a bit of a cop out. That looked like a 0. Yeah? Let's see what they said. Yeah, the area approaches 0 and the perimeter approaches infinity. Right, hope that helps.